Hello and welcome to helpyourmath.com. In this video, we're going to look at the graphs of tangent and cotangent functions. First, let's just review what those are and characteristics for the graphs. So a tangent graph, what it normally looks like is we have a vertical asymptote at x equals negative pi over 2 and a vertical asymptote at pi over 2. So that means that the origin is right directly in the middle, and so there would be a key point at the origin. The key point at the origin is where the graph shifts from being concave down to concave up. Other key points in this particular period would be at negative pi over 4, negative 1, and pi over 4, positive 1. This graph to me reminds me of like a cubic function that's wedged in between asymptotes. So it would look like this, and then we hug that asymptote there. This is a periodic function, so we would see that again repeated here at 3 pi over 2, and it'd have the same characteristics. It'd look like that, and so we'd see that over and over and over again. That's what makes this a periodic function. Okay, when we're graphing transformed tangent graphs, there's a few things we look for. One is we might see a change in amplitude. That's, looking at the absolute value of A, and that determines if there's a stretch or a shrink. But more important is figuring out where the periods are. So the period might change if there's a value for B or a value for C or both. In order to find the lower asymptote, the lower bound asymptote, so the one that's at negative pi over 2, we take what's within the function, within that tangent, and we set it equal to negative pi over 2 to find the lower bound. Then we solve for x, so we have x equals something. I guess in this case it would be negative pi over 2 plus c all divided by b. That's a little gross looking, and normally it's not going to look like that. And that would tell us where the lower bound vertical asymptote is for one period. For a second period, we would take that same thing within the tangent and we would set it equal to pi over 2 and solve for x there as well. To find another asymptote, what I look for is I just look for the difference between the lower bound and upper bound, and I know that that's going to be the difference between all periods. So you can add it on to the upper bound or you can subtract it from the lower bound to find another vertical asymptote. Then we want to identify maybe those three key points. So one is always going to be in the middle of the asymptotes. It might also be an intercept, so then you could look in between the middle and one of the asymptotes to find another point, just to get an idea of what the graph will look like. Okay, how about our cotangent graph? So cotangent to me kind of looks like a negative cubic function. We have a vertical asymptote at x equals 0 and at x equals pi. So this would be our y-axis, and then there'd be a intercept at pi over 2, and then pi over 4 would have a point at 1, and 3 pi over 4 would have a point at negative 1. And so it kind of comes up and then it goes down. So it starts out being concave up and concave down, but it's always going in the negative direction. Again, this one's periodic, so we would have another one over here with a point in the middle, and it would have that same look. And that's going to repeat over and over and over again for our cotangent graph. Again, the amplitude determines whether there's a stretch or a shrink. And then to find the asymptotes for our cotangent graph, we would find the lower bound by taking what's inside the parentheses, bx minus c, and setting it equal to 0. The upper bound would be bx minus c is equal to pi. Then we would find some key points, such as intercepts, and that in the middle of the asymptotes to get a sense of the shape within the middle. We know it's going towards positive infinity on the left and negative infinity on the right, but what about kind of in the middle? All right, so let's look at a few examples. First, we're going to sketch a graph of y equals 3 times tangent of x over 4, and we want to include 2 full periods. So the 3 indicates to me that we're going to have an amplitude of 3. So whereas normally the y values are 1 and negative 1 or negative 1 and 1, here we're going to see them be negative 3 and 3. The other thing we want to do is we want to figure out the period. To figure out the period, the lower bound, remember how we do that? This is for tangent. So tangent is we take what's inside the tangent function itself, x over 4, and we set it equal to negative pi over 2, solve for x. To solve for x, I'm going to multiply both sides by 4. This would be negative pi over 2 times 4 over 1. That's negative 2 pi. Then to find the upper bound, I take what's inside the parentheses, and I set it equal to pi over 2. So I'm going to multiply by 4, and again, we're going to see x equals 2 pi. Okay, so now I want to get a sense of what this graph will look like. I'm going to count by half pi's. So this is going to be negative pi over 2. This will be negative pi. negative 3 pi over 2, negative 2 pi. Same thing over here, pi over 2 pi, 3 pi over 2, 2 pi. And we have a vertical asymptote, and I'm going to do the best I can with this. It's really hard with the keyboard below. There we go. And 2 pi. Okay, so a few things we know. We can find another vertical asymptote because what's the space between the two asymptotes here from negative 2 pi to 2 pi? That's a change of 4 pi. So we could either go to the right of 2 pi or to the left of negative 2 pi. If I go to the right of 2 pi, this would be 3 pi. Here's the middle, 4 pi, 5 pi, and there it is, 6 pi is going to be 4 pi more than 2 pi. So I have another vertical asymptote here. Okay, but now looking within the first set, in between negative 2 pi and 2 pi, so what value is exactly between negative 2 pi and 2 pi? That would be 0. So we know that there's going to be a point at 0, 0, and if you don't like playing that middle game, you can always say, okay, well, what's going to make the inside the parentheses equal to 0? So x over 4 equals 0 when x equals 0, and then it would be tangent of 0 is 0, and 0 times 3 is 0. Okay, let's find 2 more points, and like I said, what we would do is we're going to go exactly halfway between negative 2 pi and 0, which would put us at negative pi. When I plug in negative pi, so I'm just going to make a little chart here. I already have 0, 0. If I plug in negative pi, that's going to give me 3 times tangent of pi over 4. Well, what's tangent of pi over 4? We should know this. We should be experts at this. Tangent of pi over 4 is 1, and 1 times... Sorry, negative pi. Right, let's try that again. Let's plug in the right way. Okay, tangent of negative pi over 4. There we go. What's tangent of negative pi over 4? That is negative 1, and negative 1 times 3 is negative 3. Okay, so now we have a point at negative pi, negative 1, negative 2, negative 3, and we are expecting this graph to be down towards the left of the middle point and then up towards the right. So next I'll plug in pi, because that's halfway between 0 and 2 pi. This would be 3 times tangent of pi over 4. Tangent of pi over 4 is 1, and 1 times 3 is 3. So that puts us at 3. And so it would be down, go through that point, go through the origin, up that way. So you can see this one does have that stretch, right? The amplitude was 3. It looks a little bit more stretched out than the parent function of tangent x. The same thing will happen in this period. So the middle will be an intercept. If we go in the middle, we'll be at negative 3. Middle will be at positive 3. And connect with a nice smooth curve. And this is periodic, so this can happen over and over again, but this just said sketch 2 full periods, so that's what we did. In our next example, we're going to look at the graph of a cotangent function transformed. Remember cotangent? It comes up from the left and down to the right over and over again. To me, it looks like a negative cubic function wedged in between 2 asymptotes. The amplitude here is going to be 1. Since there's nothing being multiplied to cotangent, it's implied to be a 1. So what we're interested in is where the period is for this graph. It looks like the period is going to be shifted horizontally since we do have a c value here. To determine the lower bound of the period, we're going to take what's inside the parentheses, 2x minus pi over 4, and we're going to set it equal to 0 and solve for x. So I'm going to add pi over 4 to both sides. That gives me 2x equals pi over 4. Then I'm going to normally we would divide both sides by 2, but since we already have a fraction and I don't want a complex fraction, the alternative is to multiply by the reciprocal of the coefficient. So I'm going to multiply both sides by a half, right? Because half of 2 is 1, so it will give me 1x. And then if I multiply over here by a half, I end up with pi over 8. So we have one vertical asymptote at pi over 8. What about the upper bound? So the upper bound, we're going to take what's inside the parentheses and set it equal to pi. Now we're going to solve for x again. When I add pi over 4 to both sides, this time since I actually have something over there, I need to find a common denominator. I'm going to put pi over 1, and then 1 and 4 we would want to use 4, so I'm going to multiply pi by 4 over 4. That will give me 4 pi over 4, and 4 pi over 4 plus pi over 4 is 5 pi over 4. Now I need to get x by itself, so again, instead of dividing by 2, I'm going to do something that's equivalent to that, which is multiply both sides by 1/2. The 1/2 and the 2 give me 1x, which is just x, and here we get x equals 5 pi over 8. So now I have the lower limit and the upper limit, or the lower bound and the upper bound of this one period. Let's go ahead and get those on the graph, and then we'll continue from there. Since both bounds have denominators of 8s, I'm going to count by pi over 8. So this would be 0 pi over 8, this is 1 pi over 8, this is 2 pi over 8, which is pi over 4, this would be 3 pi over 8, 4 pi over 8 would be pi over 2, 5 pi over 8, and that would be what we need, right? Because we have pi over 8, check, 5 pi over 8. Now we want to draw on the vertical asymptotes. And because I'm so bad at drawing vertical lines, I did it ahead of time. So there's one vertical asymptote and there's the other vertical asymptote. Now let's look within this vertical asymptote to see what this graph is looking like. We might want to set up a table of values to help us. I certainly find that it helps me. So I'm going to say x and y, and we want to pick 3 values, and the 3 values are already labeled on the graph. So I want to use pi over 4, 3 pi over 8, and pi over 2. If I didn't label them, I usually like to start directly in the middle at the 3 pi over 8 because I'm expecting that to be an x-intercept, especially because there's no vertical shift in this graph. It really should be 3 pi over 8 comma 0. So maybe I'll start there just so that way I know that I'm doing something right, and then I'll go back and look at pi over 4 and pi over 2. So if I plug in 3 pi over 8, I would have y equals cotangent of 2 times 3 pi over 8, that would be 2 over 1, minus pi over 4. Well, 2 times 3 pi over 8 would be 3 pi over 4. 3 pi over 4 minus pi over 4 would give me 2 pi over 4, or pi over 2. What's cotangent of pi over 2? Well, if we think about what that means, so thinking back to the unit circle, a point associated with pi over 2 is the point 0, 1. Cotangent is x over y, so that'd be 0 over 1. So cotangent of pi over 2 is 0, and that's exactly what we were expecting. So I feel pretty good that I've done something right so far. Okay, what happens if we plug in pi over 4? Now I really have no space. We'll go up here. We have y equals cotangent of 2 times pi over 4 minus pi over 4. So this would be, I'm not going to simplify this one because they already have a common denominator and we're going to have to subtract. So this is 2 pi over 4 minus pi over 4. That's pi over 4. And what's cotangent of pi over 4? Well, tangent of pi over 4 is 1, and the reciprocal of 1 is 1. So that would be a 1. And we were expecting it to be positive to the left of that middle point, so we're so far so good. Last one, we're going to plug in pi over 2. So we have y equals cotangent of 2 times pi over 2 minus pi over 4. If you want to simplify this, you can. However you want to work this one. So if we simplify it, we end up with just pi minus pi over 4. And do you know what pi minus pi over 4 is without finding the common denominator? Well, what would complete the pi would be 3 pi over 4. So we would end up with cotangent of 3 pi over 4. And cotangent of 3 pi over 4, well, that would be 3 pi over 4. Tangent, that would be negative 1. And the reciprocal of negative 1 is negative 1. So cotangent of 3 pi over 4 is negative 1, which is exactly what we expected, right? Because there's no amplitude, so we were expecting to see some 1s here. And then the graph hugs the asymptote, coming down, 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 down. Now it shifts to concave down, all the way down. This was one complete period. To find a second period, we don't need to do all this work again. We're just going to say, okay, what's the difference between the asymptotes? How much space is there? What is the period? The period goes from pi over 8 to 5 pi over 8. That would be a change of 4 pi over 8. And I'll leave it like that because we're going to need that denominator. So we can either go to the right of 5 pi over 8, or we can go to the left of pi over 8. I like just sticking with the positive, so the next period would be 4 pi over 8 units this way. That would put us at 9 pi over 8. So this would be 7 pi over 8. This right here would be 9 pi over 8. And so there's going to be another vertical asymptote here. And then those key points are going to be identical. So in the middle of the asymptotes, there's going to be an x-intercept. To the left, we're going to have the positive one, and to the right, we're going to have the negative one. And it repeats, right? So once we do the work for one, we don't need to do it again. This is cyclic, so it would just be adding 2 pi to everything. Basically, in the unit circle, that's what it would be doing. And we would just see that again and again. Okay, we survived the graphs of tangent and cotangent. Now we're going to be given the graphs, and we're going to work backwards to figure out what the equations are. Okay, in this example, we're given the graph. And is this a graph of a tangent function or a cotangent function? We assume that it's a tangent function because it does look like positive cubics all over the map here. Let's figure out a few things. So first, let's figure out where one period ends and begins, or begins and ends. It looks like here at negative pi, we have a vertical asymptote, and at pi, right? You can see the graph is hugging in between those asymptotes. So what we need to figure out, a few things, since it starts on, since there's a point at 0, 0, and that happens to be a middle point, that indicates to me that c is equal to 0 and d is equal to 0. So what we're looking at here is plugging in to a times tangent of bx. So we need to figure out if there's an amplitude, and we need to figure out what the value of b is. I figured out b a little bit sneakily is what I did. So what I know is that we have an x, so I'm going to talk about the lower bound here. The lower bound, the x asymptote, is x equals negative pi. The other thing I know is that in the equation, that bx plus c, but since c is 0 I can forego that, has to equal negative pi over 2. So what this indicates to me is I need to work with these two equations to figure out the value of b. And so what I did is I took this top equation and I multiplied both sides by b. And the reason I did that is because now these match. So I can use the transitive property to say, well, if those match, then these must also be equal. So that means that negative pi times b must equal negative pi over 2. Now I can figure out the value of b by dividing both sides by negative pi or multiplying by the reciprocal of negative pi. I'm going to actually do that over here. So now what we see is that negative pi and negative pi cancel, and we end up with b is equal to 1/2. Yay! Okay, so I know that b is equal to 1/2. I know now I need to figure out the value of a, and then we'll work back and actually answer the questions because it does ask for the amplitude and period and equation. So I think I'm actually going to get the equation first, and then I'll go back and state what the amplitude and period were. So then, now that I know b, what I can do to figure out the amplitude is pick any point. I can't choose any of the x-intercepts, but I could choose this beautiful point right here, negative pi over 2, 2, and plug that in for x and y to figure out if there is an amplitude besides 1. So this is x, this is y, this is b. This would give me 2 equals a times tangent of b, which is 1/2 times pi over 2. I'm going to clean this up. 1/2 times pi over 2 is pi over 4, and tangent of pi over 4 is 1. So I get 2 equals a times 1, because this whole thing just equals 1, which indicates to me we have an amplitude of 2. So now I think we're ready to answer all three parts of this question. The amplitude is 2. I guess I could say capital letter A. The period, so remember, to find a period, we look at the space between the asymptotes, and that would be from negative pi to pi is 2 pi. And the equation, I'm going to put it, let's see if I can squeeze it in here, is going to be y equals 2 times tangent of 1/2 x, or x over 2, whichever way you want to write that is fine. And that would be it. Voila! Beautiful, isn't it? Okay, in our last example, let's see what we have. This appears to be a cotangent graph because it looks like negative cubic functions all over the place. Looking at just identifying a period here. So we have one at 0, one asymptote at 0 and one asymptote at 3 pi. So I know that the period is 3 pi. Now I need to figure out the amplitude and the equation of this cotangent graph. Before I figure out the amplitude, what I notice here is that directly in between 0 and 3 pi would be 3 pi over 2, and that does appear to be an x-intercept. So that makes me believe that there's no vertical change. And because we have a asymptote at 0, that indicates to me that there's no horizontal change, which means c is equal to 0 and d is equal to 0. So what we want to build is we want to build the equation y equals a times cotangent of bx. Now we need to figure out the value of a and the value of bx. So what I like to do is I like to say, okay, well, we have a vertical asymptote. I'm going to use the upper bound here. The upper bound is x equals 3 pi. And what should that have been? That should have been that bx is equal to pi. So we need to figure out the value of b by using these two equations. Since I have b times x here, I can pretty quickly get b times x here by multiplying both sides by b. Now I can kind of set these equal to each other, right? Because we have bx equals bx, so that means these must be equal to each other. That gives me 3 pi times b is equal to pi. Get b by itself by dividing both sides by 3 pi. and that would be b equals 1/3. All right, so now we know b. The only thing we're missing is if there's an amplitude. So the way that I figure out the amplitude is I plug in 1/3 for b, and I find some other point on the graph to use to plug in for x and y. So let's see if we can find a nice point on the graph. This one's a little bit mean. I think right here we're going to see a nice point. This appears to be directly in between 2 pi and 5 pi over 2. And that would be, so if we put those in fourths, that would be 8 pi over 4 and 10 pi over 4. So that must be 9 pi over 4. Okay, maybe it's not the nicest point. And -4. So let's see what that gives us, because I don't see any other nice points. No. All right, so we're going to plug this in for x and this in for y, and let's see what happens. We get -4 equals a, let's not forget what we're solving for here, a times cotangent of 1/3 times x, and we're replacing x with 9 pi over 4. So this would be 1, this would be 3. Okay, so we have -4 is equal to a times cotangent of 3 pi over 4. And what is cotangent of 3 pi over 4? Well, tangent of 3 pi over 4 is -1, and this would be the reciprocal of that, so we get -4 equals a times -1. If we divide both sides by -1, we figure out that a is equal to 4. So now we have all of the ingredients we need to write this equation. We know that the amplitude here is 4. We know that the period is 3 pi. And we know that the equation of this graph is given by y equals 4 times cotangent of, what was b? 1/3 times x, or you could put x over 3. So those are the 3 pieces of information that were being asked, and we did it. These have been examples of looking at cotangent and tangent graphs. Thank you for